It's great to see you again. My name is Dakar, and let's get started. This guide will be useful for all Intel processors, and for all DDR5 motherboards. So, in order for us to start overclocking, we need to make sure that we have SK Hynix chips. This guide suits only for these chips. If you have other chips, then subscribe to the channel, and wait for the video. I'm planning to make a video for Samsung and Spectec chips. If you want to know what chips we have, we need the CPU-Z program. In the CPU-Z program, go to the SPD tab, select slot 2 or slot 4. If it says SK Hynix, then this guide is for you. After that, I advise you to update the BIOS of your motherboard, since the microcodes for DDR5 memory are still being finalized, and with each BIOS update, the memory overclocking is getting better and better. How to update the BIOS? Look for instructions on the internet. It's simple. We will also need the programs IDAS64, TestMum5 with 1 Osmos v3 configuration, and just in case Extremianta 777, also CPU-Z, Hardware Info 64, and also you should have any very demanding game that loads the processor, such as Call of Duty Warzone, Battlefield, or at least Shadow of Tomb Raider. Also I recommend you to purchase RAM Test Karha. This test checks DDR5 RAM very well, so I recommend you to purchase it. Also pay attention to which slots you have RAM in. Before you start the test, if you have 4 slots and you have 2 RAM modules, you should place the RAM in slots 2 and 4. The slots are numbered from the side of the processor. For newbies, I remind you that when you turn on the PC, you need to press the delete key to enter the BIOS. If you previously had any overclocking, it is better to reset it to default. On my MSI motherboard, this can be done using the F6 key, then press enter, F10 and again we go into the BIOS. Or if you have a different motherboard, look for the Exit tab, and find the Load Optimized Defaults option. Next, we go to the overclocking menu on MSI, press OC, and go to the most difficult one, namely Voltage Settings. Then we are interested in CPU SA voltage mode. It differs from the one on DD4, so the rules by which we used to set the voltage are now no longer suitable. At the moment, on DDR5, the easiest way is to leave it either in auto, or if the system overestimates the CPU SA voltage, this should be monitored using the HW Info program and fixed at low values. This is 1.1 volts or 1.25 volts. 1.25 is enough for very high frequencies. We will set it manually right away. Remember that after all the manipulations with overclocking, we can reduce this value. One of the most difficult voltages is the CPU VDDQ voltage. This voltage is one of the most difficult, but also the most important. If there are any instabilities, then first of all, you need to pay attention to this particular voltage. The lower the better, so too high voltage often causes additional instabilities or errors, but you should not lower it too much. Usually 1.25 volts is enough. This is even considered a high value. If you have a motherboard with 2 RAM slots, then usually even 1.1 volts is enough to get 7000 MHz on DDR5. We will put it at 1.25 volts. Next we are interested in drum voltage. First of all, set on link in order to separate drum voltage and VDDQ voltage. The first 2 columns are the voltage to the RAM, directly to the modules themselves. So what should be the value? The range of values is approximately from 1.35 to 1.5 volts, but set it to 1.5 volts if you have active airflow for RAM and good cooling radiators. Set the value to 1.35 volts if the modules are without any airflow and without cooling radiators at all, but you need to monitor the temperature of the RAM. It is drum voltage that affects the heating of RAM. For DDR5, the recommended temperature is up to 60 degrees. At temperatures above 60 degrees, errors usually occur. An excellent temperature can be considered if indicators is below 50 degrees. Ideally, the temperature should be kept below 50 degrees. Due to the airflow on my RAM, I put 1.5 volts on both modules. The developers allow us to set our own voltage for each module. This can be done if one module turned out to be better than the other, but this is already a very fine tuning, but we set the same value. Next, drum VDDQ voltage. Often on motherboards they are dual, and you need to separate them through a special menu, as we did earlier. As you can see, the motherboard hints to us that we need to use drum VDDQ voltage in approximately the same range as drum voltage. But I suggest set it up about 0.06 volts lower. So, if we have 1.5 volts drum voltage, then we set the drum VDDQ voltage to about 1.44 volts. And we are also interested in CPU VDD2 voltage. This parameter should be set to 1.35 volts. This value is usually enough even for 6600 MHz. We fix the CPU VDD2 voltage immediately at 1.35 volts, and, if it is necessary to reduce or increase, we will do it. On DDR5, as you already understood, it is important not to overestimate the voltages. Next, we move on to frequencies. We are interested in DRAM setting and a few minor settings. We only need to set a few settings. The first is we need to set memory fast boot in disable. Next, set the DRAM reference clock to 133 MHz. The next CPU IMC DRAM clock, Gear 1, does not work on Intel at the moment, so we install Gear 2 and work with it. Then we are interested in DRAM frequency. Here I recommend setting 5333 MHz at the beginning, and then we will look for the maximum frequency at which our motherboard starts. We go to Advanced DRAM Configuration. Here, we are interested in a section called MISC item. In this section we need only one parameter. If you have two modules of 16 GB of RAM, then most likely you have dual rangs. We find Enhanced Interleave. It facilitates overclocking dual rangs RAM, and set enable mode. But if you have two 8 GB modules, leave it in the auto mode. Before the primary timings, I suggest setting the command rate. At the moment, when I write the guide, command rate 1N on DDR5 either does not work or works but with problems, so I suggest setting it to 2N. Next, tCWL. There is a feature, it must always be even, like 38, 40, 32, 28 and so on. An odd value does not work. First, let's set the average high value of TSL as 36, so that it does not interfere with us looking for the maximum allowable frequency of our memory modules. Next, tRCD. This item is not related to tCWL, but it also scales well from voltage. The higher the voltage to the RAM, the lower tCWL and tRCD will fall. On RAM with an SK Hynix chip, it's better to slightly overestimate relative to tCWL by about 8 points. If we set tCWL 36, then we set tRCD to 44. Actually, it's not worth lowering tRCD to the minimum. Of course there is boost from tRCD, but we are talking about a completely meager increase. Next, tRCDW and tRP, we also set it to 44. TRAS should be calculated according to the formula tRCD plus tRP. The tRP item is in the secondary timings. On DDR5 it is almost always at a value of 12, respectively. 12 plus 44 is equal to 56, so we set TRAS to 56. I also recommend setting TFAW to JEDEC at 32, the tests will pass faster. That's it, press F10 and enter, go back to the BIOS. Select the OC tab, and proceed directly to the selection of the maximum frequency in drum frequency. We select a frequency higher than the original one. I will look for the maximum frequency by increasing by 400 MHz, start with 6133 MHz, F10, and enter. Go into the BIOS again by pressing the delete key. Do not forget to periodically save overclocking. In case of errors it will be problematic to set all the settings again. On MSI, profile can be saved by pressing the F9 key, then select one of the empty profiles and enter. That's it, we saved. To load the profile, press the F8 key. If suddenly our motherboard does not start, then there are two options. The first is to wait until the motherboard starts up by itself, and the second option is if our motherboard freezes, you need to turn off and turn on the PC until the black screen will appear. With F1 button, press F1 and you will get into BIOS again, and then load the previous stable overclocking profile. And if it does not help, then look in the instructions for your motherboard, where clear CMOS is located. These are two pins, you need to short them to each other. This can be done with a metal object, or you can pre-connect the reset button if you have it on the case or separately. And the next option is when your PC is completely de-energized, we pull out the battery for about a minute. Do not forget to lick the battery and put it back in. After that our computer will turn on. We continue to look for the maximum frequency, then we set 6400 MHz, F10, and enter. If we booted, then do not forget to save the profile and increase to 6666 MHz, F10, and enter. We booted up again, save the profile, then 6933 MHz, F10 and enter. We booted up and got into Windows. But since I have SK Hynix M-die, the frequency will most likely not be stable. Therefore, we will now check for stability. I will leave a link with necessary programs in the description, but I advise you to find these programs yourself. Perhaps there is a more up-to-date version. The easiest way is to check it in RAM test. It finds errors very quickly, or if you don't have RAM test, then use tcm5, run as administrator. I advise you to immediately put a normal preset, click configure and look for the folder with this test, then select the profile 1 usmas v3. We run tcm5 again, as administrator and check for about 15 minutes. Since I bought RAM test Karha, so I will use it. While our stress test is in progress, we will check the temperature of our RAM. For this we go to HWinfo64, press sensors only, then we go down and find the RAM sensors. At the moment one module heats up to 42 degrees, and the second module is 39.5. It is a fairly low temperature, so don't worry. Also, to see what the frequency we have set, run CPU-Z, go to memory and multiply DRAM frequency by 2, that is, now we have almost 6916 MHz when tCL is 36. If you have a blue screen at this stage, or the computer has rebooted, or there are errors in tcm5, then reboot. Decrease the frequency or increase the voltages. As you can see, I have an error. If there is at least one error, then you need to stop the test and start to correct your overclock. In my case, I will not raise the voltage, but rather lower the frequency to the previous value, but it is not necessary to set 6666 MHz. We can change the DRAM reference clock to 100 MHz and set 6800 MHz. It is likely that 6800 MHz will be stable. Press F10 and enter. Let's run the test again. While the test is in progress, make sure that the board sets exactly the voltage that we have set. So RAM is 1.5 volts, VDDQ voltage is 1.44 volt. The second module is the same. VDDQ TX voltage is 1.25 volts as we set. I remind you that you can experiment with it, sometimes lowering it gives additional stability and errors disappear. But since we have an introductory guide, we won't do fine-tuning. We test for about 20 minutes, if everything goes without errors, then we will go directly to the timings. So 20 minutes passed, one of the modules warmed up to 47 degrees, the other one to 43, and all this at a frequency of 6800 MHz with a CL value of 36. Next, we proceed to the selection of primary timings. Before setting up, need to save our profile. CL selection works according to the principle 1 CL unit is approximately 100 MHz, respectively. If you manage to overclock the frequency of 6800 MHz with CL34 and 6600 MHz with CL30, then it is more profitable for you to put 6600 MHz CL30. I'll try to set 6800 MHz CL32, press F10 and enter. As you can see, my PC did not start with the settings, respectively. Press F1, go into the BIOS and set CL34, press F10 and enter. It didn't start again, so we'll try 6600 MHz, but CL32, F10 and enter. We boot into the BIOS and see that 6600 MHz CL32 is available for us. But now we are wondering whether the 6600 MHz CL30 will launch or not. And we did it. Now we will test the 6600 MHz CL30 for errors. By the way, the 6600 MHz CL30 will be better than the 6800 MHz CL34. We start with a cache and memory test to make sure we didn't make any mistakes. Perhaps we have reduced some values too much. As you can see on the right in copy, it's a bit low. But that's because we have the primary and the secondary timings are not yet fully configured. Let's start the test. So the 6600 MHz CL30, as we can see, works for almost 20 minutes. The heating is also insignificant. We selected the CL30 parameter. Next is tRCD parameter. It's selecting according to the TCL principle by decreasing. But for myself I decided to leave it to 38 and tRCDW and tRP will also be set to 38. TRAS is tRTP plus tRP, so 38 plus 12 will be 50, excellent, F10 and enter. We run cache memory benchmark. The first thing we notice is a low writing. Perhaps the problem is in the secondary timings, because we already set the primary ones. We start RAM test. Good, we figured out the primary timings, 10 minutes have passed and there are no errors, tRCD is configured correctly, you can try to lower it even more, but I think it's not worth the waste of time. But if you want, you can try lowering this value even lower. Now let's move on to secondary and tertiary timings. Let's start with tRFC2, it shall be a multiple of 8, for example when dividing the value 368 by 8, we should get an integer without a remainder. I think you understood, but remember, if you lower the tRFC too much, that won't do much either. Next is tRFCpb, this parameter does not particularly affect the FPS, we set it about 240. Next is tREFI, I set it to 65,024 same as on DDR4, but tREFI affects the heating of RAM. After you set tREFI to 65024, restart the system and run tSMM5, at least 10 minutes, if errors start immediately, then divide this value by 2, that is, set 32012, but if there are still errors, then it's better to leave it in auto. Set tWR and tWR to 48, then press F10 and enter, and boot into BIOS again and save the profile. We will not set the next two timings yet, they are set through tertiary timings, like tWRRDSG and tWRRDDG, so we'll get back to setting them up a bit later. We also set tRTP to 12, sometimes this parameter can be lowered to 10, and rarely even to 8, but I do not recommend lowering this value too much, because we are not going to set records here. We set tCWL either equal to tCL, or we make tCL-2 is equal to 28. So tCWL is 28. Then tCKE is either 8 or 10 or 12, 8 strong compression, 10 medium, and 12 for high frequencies. In our case 10 will be enough. Then F10 and enter. Let's see how our settings affect cache and memory benchmark. Tuning had a very good effect, reading, writing and copying grew, latency became lower. But writing still does not satisfy me. Now I will try to make an experiment, tCL is responsible for reading, tCWL is responsible for writing. There is a possibility that our tCWL is now very low, that is, I suggest raising its value up to 30 and see how the situation changes. We go into the timings and change the value to 30. But unfortunately, the writing didn't react much, accordingly, the problem may be in tertiary timings. A short Kara test did not show any errors. The heating is not significant, I think if you wait 20 minutes, the heating will also be up to 47 to 49 degrees. Let's move on to the tertiary timings. Change turnaround timing setting mode to fixed mode. Next, in this group of parameters, set the same values as mine, press F10 and enter. After running the test, we see that the write and copy has now increased, but I did not set the tCWL back to 28. Let's set tRRD8 and tRRDL to 12 and return tCWL to 28, then press F10 and enter. We go into the BIOS, look for TXP and set it to 8, this will help us reduce the latency a little. Also we set power down mod in disable, and here we also set 0. Press F10 and enter. Cache and memory benchmark is finished and we see an increase in the value and a decrease in latency to 57. And this completely satisfies me, although we have not yet overclocked the processor and everything is in auto. In the future, when the processor is overclocked, this memory value will also increase. Now we need to pass all tests for stability and no errors. For tSMM5 apply the configuration from 1 Osmos and Extremianta 777. If we have a Karha test, then we need to go through about 8 hours of the test. Yes, this is not a joke. For a complete check you need to test this much time. After we made sure that everything is working stably and 8 hours of the test have been passed, we go into the BIOS and save the profile. Do not forget to reduce the voltages after overclocking because we set them with a small margin and also rerun stability tests. Also test overclocking in games by setting the minimum quality settings and minimum resolution in games and playing Warzone. The game will load the processor and RAM very well. Games like Call of Duty Warzone, Battlefield, or at least Shadow of Tomb Raider reveal poor overclocking quite quickly. Keep this in mind and use for tests. After you have configured all the necessary voltages, you can switch memory fast boot to enable or no training. This parameter will allow the computer to turn on faster, and it is less likely that the motherboard in the BIOS will reset the timings to auto. Each of these parameters needs to be reduced a little bit and tested for stability, but it's not easy and fast. But if you want to reduce memory heating and remove possible errors, then you need to do this and do a stability check every time. After you have configured all the necessary voltages, you can switch memory fast boot to enable or no training. This parameter will allow the computer to turn on faster, and it is less likely that the motherboard in the BIOS will reset the timings to auto. Well, this is where I end my guide. If it was useful, leave a like and subscribe to the channel. I wish you high FPS and low input lag. See you.